And we are back. Tonight's episode will feature video lessons in mathematics and science. These video clips are the sweat and blood of our own teachers to support the different learning modalities being implemented in STO Cabanatuan City. Join us, watch, and learn from our first set of Tele-Turuan clips in mathematics.
Good day! Welcome to Tele-Turuan. This is the fourth episode in Mathematics 10 for the second grading period. I am Hannah Pamela C. Bautista, a teacher from Honorato C. Perez Senior Memorial Science High School, and I will be your teacher presenter for today's session. Now we are going to talk about theorems on chords, arcs, central angles, and inscribed angles. Now today, our objective would be to understand the theorems involving chords, arcs, central angles, and inscribed angles, and to use these theorems to solve simple problems. Now this is in line with our most essential learning competency, which is proves theorems related to chords, arcs, central angles, and inscribed angles. Now before we start our lesson, let's try to do a little recall. What is this word? This is a segment joining any 2 points on the circle. Do you know what it is? Yes, it's a chord. Let's look at our next word. What is this? It's an angle whose vertex is on the circle's center and whose sides intersect the circle at 2 points. Do you know what it is? Yes, it's the central angle. Now let's look at our third word. This is a portion of the circle determined by a central angle. Guess what it is? Yes, you're right, it's the arc. Now for our last word. This is an angle whose vertex is on the circle and whose sides contain chords on a circle. Yep, you're right again. This is the inscribed angle. Okay, who's ready to learn some theorems? Let's start with theorem number 1. In a circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding angles are congruent. Now notice the special phrase if and only if. This means our theorem is a biconditional statement. It means that the if-then statement and its converse are true. Now to have a visual of this example, I have here 2 circles, circle E and circle I, with some points and an inscribed angle, angle SET and angle BIG respectively. Now if you are given that angle SET is congruent to angle BIG, then according to this theorem, arc ST and arc BG are also congruent. Now conversely, if you are given arc ST is congruent to arc BG, then you can conclude, according to this theorem, that the 2 angles, angle SET and angle BIG respectively, are congruent as well. Okay, now let's look at theorem number 2. In a circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. Now notice we also have our special phrase if and only if, which means this is also a biconditional statement. Now to give you a solid example, we have here circles T and circle N. Notice that they have 2 chords, chord AB for circle T and chord OE for circle N. Now given that these 2 circles are congruent and that chord AB is congruent to chord OE, then you can say that the intersected arcs, arc AB and arc OE respectively, are congruent as well. Now let's look at the converse. The converse of this is if you are given the arc AB and arc OE to be congruent, then their respective chords, chord AB and chord OE, are congruent as well. Got that? I sure hope you do. Now let's look at theorem number 3. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. Now notice, this is also a biconditional statement, so I will be giving you 2 examples, the if-then statement and its converse. Now here we are given circle A with several points, a diameter, and a chord. Now given BE in our circle A is a diameter and it is perpendicular to given chord CD, according to this theorem, it will bisect chord CD, which means that you have chord or segment CF is going to be congruent to chord FD. Now, it doesn't just bisect the chord, it also bisects the arc that intersects, which means that arc CE is also congruent to arc D. Alright, so now let's look at theorem number 4. If two inscribed angles of a circle, or congruent circles, intercept congruent arcs, or the same arc, then the angles are congruent. I have here two examples that I would like to show you that discusses this theorem. So first I have circle T, and I have 4 points given. I have point P, O, I, and N. Notice that I have two inscribed angles, angle IPN and angle NOI. Now, what do you notice about these two inscribed angles? They intercept the same arc, right? So they have arc IN. Now, according to theorem number 4, if two inscribed angles intercept the same arc, then the measure of these angles are congruent. Here I have the second circle, circle M. We are given angles OPT and angle WNE. Now, given that angle OPT and angle ENW are inscribed angles, and that the arcs OT and arc EW are congruent, then we can say that the two inscribed angles are congruent as well. Now let's look at the fifth theorem. I hope you're still listening. This is our fifth theorem for today. If an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. Let's look at our example. I have here circle O, and as you can see, there is an inscribed angle NTE. It intercepts arc NSE, which, as you can see, is a semicircle. This means that the measure of angle NTE is 90 degrees. All right, so let's exercise those brain cells of yours and let's do some exercises. Now, I have here circle B, and I am given that chord AT and chord MN are diameters, and arc NT is congruent to arc AM. Now, I would like you to name a pair of congruent chords. Think about it. Now, who got this one right? Chord NT and chord AM are congruent. Why is that? It's because of our theorem number 2. Let's look at the second item. We're still given the same circle. Now, our question is, name a pair of congruent central angles. You're still given arc NT and arc AM to be congruent, right? So that means, according to theorem number 1, we can say that the central angles NBT and MBA are congruent as well. Good job! Now we have our third number. Name a pair of congruent inscribed angles. Now, of course, there are several answers that you can get from this item, but I would like to give attention to arc NT. Notice that for arc NT, there are two inscribed angles that are intercepting the same arc. Now, what are these two? You have angle NMT and angle TAN. According to theorem number 4, if two inscribed angles intercept the same arc, then these angles are congruent. So you got that right. And that concludes our Tele-Turuan session for today. I hope you learned something from me. I'll see you again next time. Bye!
Good day, everyone. Welcome to our new episode of DepEd Tele-Turuan. I am Marlon P. Moctal, Master Teacher 2 of Kabu Elementary School. Our lesson for today is about solving routine and non-routine problems involving division without or with any of other operations of decimals and whole numbers, including money, using appropriate problem-solving strategies and tools. Before we start, let us read the problem. Joey bought 5 packs of pineapple juice for 46 pesos and 25 centavos. How much does 1 pack of pineapple juice cost? In analyzing this problem, let's follow the steps in problem solving. And what are those steps? First is understand. Second is plan. Third is solve. And fourth is check and look back. In understand, what is asked on the problem? Very good. The cost of 1 pack of pineapple juice. And what are the given? Excellent. 5 packs of pineapple juice for 46 pesos and 25 centavos. The second step is plan. Under this is what operation to be used. Correct. Division. And what is the number sentence? Very good. 46 pesos and 25 centavos divided by 5 is equals to n. So let us solve. 46 pesos and 25 centavos divided by 5. Dividing decimal numbers is just like dividing a whole numbers. Always make sure that divisor is a whole number. So what is your answer? Excellent. The answer is 9. And 9 times 5 is equals to 45. Then 46 minus 45 is equals to 1. After that, we bring down 2. So 12 divided by 5 is what number? Right. The answer is 2. We place the decimal point in the quotient. So 5 times 2 is equals to 10. And 12 minus 10 is equals to 2. So we bring down 5. So it becomes 25. 25 divided by 5 is what number? You're right. The answer is 5. Then 5 times 5 is equals to 25. And 25 minus 25 is equals to 0. So 9 pesos and 25 centavos is the cost of 1 pack of pineapple juice. To check, 9 pesos and 25 centavos times 5 is equals to 46 pesos and 25 centavos. Let's try to solve another problem in division of decimals including other operations. Let us analyze problem number 2. Jose has 20 pesos and 50 centavos in her pocket. Her mother gave him additional 200 pesos allowance in 3 days. How much allowance does he have each day? So the first step is understand. And under understand is what is asked on the problem. Excellent. Allowance does he have on each day? What are the given? Correct. 20 pesos and 50 centavos in her pocket and 200 allowance in 3 days. So we move to the second step, which is the plan. What are the operations to be used? You're right. Addition and division. And what is the number sentence? 20 pesos and 50 centavos plus 200 pesos divided by 3 is equals to n. So the third step is solve. But first, we're going to add 200 pesos plus 20 pesos and 50 centavos is equals to 220 pesos and 50 centavos. And 220 pesos and 50 centavos divided by 3, the answer is what? Correct. The answer is 7. So 7 times 3 is equals to 21. Then 22 minus 21 is equal to 1. So we'll bring down 0. So it becomes 10. 10 divided by 3 is equals to 3. Then 3 times 3 is equals to 9. Then 10 minus 9 is equals to 1. So again, we bring down 5. So it becomes 15. 15 divided by 3 is what number? Very good. The answer is 5. 5 times 5 is equals to 0. And last, we'll bring down 0. 0 divided by 3, the answer is what? Excellent! The answer is 0. 0 times 3 is equals to 0. And 0 minus 3 is equals to 0. The answer is 73 pesos and 50 centavos. Allowance does he have each day? To check, 73 pesos and 50 centavos times 3 is equals to 220 pesos and 50 centavos. Thank you for watching. Again, this is Marlon P. Mactal of Cabu Elementary School. Keep safe, everyone. See you around! Good day, everyone. Welcome back to DepEd Tele-Turuan. Again, I am Marlon P. Mactal of Cabu Elementary School. Today, we will study about visualizing the ratio of two given numbers. But before that, let us first read the simple problem. 2 trays of egg contain 12 eggs. What is the relationship of the trays of egg to the number of eggs? If we analyze the simple problem, we are looking for the relationship between the numbers or the comparison of two quantities, and it is called a ratio. A ratio is a comparison of two different things or numbers, and a relationship between numbers by division. Going back to the problem, what is the relationship of the trays to the numbers of eggs? Very good. The relationship is called a ratio. The ratio is 2 trays of eggs is to 12 eggs. Now, a ratio can be written in 3 ways: ordered pair, fraction, and column. If you will write it in ordered pair, it will be 2 and 12. In fraction, 2 is the numerator, which is the number of trays, and 12 is the denominator, which is the number of eggs, or 2 over 12. If we write it in a column form, we write it as 2 colon 12, or which read as 2 is to 12. But can we write the number of eggs to the trays of eggs in a ratio? The answer is yes. The ratio you can form is 12 eggs is to 2 trays of eggs. If you write it in ordered pair, it is 12 and 2. In fraction, it will be 12 over 2. And in a column form, we can write it as 12 is to 2. Remember that the order of the two quantities is very necessary in expressing the ratio. So be very careful in writing the order of the two quantities. Let us try example number 2. What is the ratio of pieces to basin? How many pieces and basin can you see in the illustration? Excellent! There are 8 pieces and 1 basin. If we write this in ordered pair, it will be 8 and 1. In a fraction, 8 pieces over 1 basin, or 8 over 1. In a column form, we write it as 8:1. Let us move to example number 3. What is the ratio of dogs to cats? How many dogs and cats can you see in the illustration? Very good. There are 3 dogs and 5 cats. If we write this in an ordered pair, it will be 3 and 5. In a fraction form, 3 dogs over 5 cats, or 3 over 5. In a column form, we write it as 3:5. Let us try example number 4. What is the ratio of cows to ducks? How many cows and ducks can you see in the illustration? Excellent! There are 4 cows and 6 ducks. If we write this in ordered pair, it will be 4 and 6. In a fraction form, 4 cows over 6 ducks, or 4 over 6. And in a column form, we write it as 4:6. Thank you for watching. I hope you learned a lot on this episode. See you around, guys. Goodbye!